data science math final project for the bridge course. I'm using the H-Flights package by Hadley Wickham. The two variables I chose are distance and arrival delay. Just off the bat, they seem like they would have some sort of relationship between the two of them to me, so I chose distance as my X variable, arrival delay as my Y variable. Now, the assignment specifies that one of the variables must be skewed to the right, have a positive skew. So there is a skew function in R you can use, but I chose to test manually by checking if the mean is greater than the median. So for the X variable, that is not the case. However, for the Y variable, arrival delay, that is the case. So my Y variable is skewed right, and I'll use that later on in the project. So the small letter x is estimated as a third quartile. So for that, I use the quantile function in R. And by default, it gives you 25, 50, and 75%. So 75% is my third quantile. I subset the results to be able to save it as a variable. Same thing here. I subset 50% to the second quartile for the Y variable. See here, I use na.rm equals true because I was having some errors thrown, and that's because there are some na values in the Y variable. So my total variable is just, I use nrow to count the number of rows. Other ways to count to make counts is by using, for example, length for distance, where distance is greater than the small variable x. That's all the values of x that are greater than the third quartile value, and so on and so forth. For x and y greater than less than, I usually use probabilities by using the p-norm function. Lower tail is false, means it's greater than. True means it's less than. I also do joint counts. So you'll see I have a little key here where underscore means and, G means given. So x is greater than x and y is greater than y. I'm using this function here. There are other ways to get this count, but this was more intuitive to me as a SQL developer because it's sort of like I'm saying I'm taking everything from the joint subset, which is both variables, where distance is greater than x and arrival delay is greater than y. And then I also do get the probability there by taking that over the total. I'm also doing posterior probabilities here, but for the A, B, C, and D questions, for the A and C are asking for posterior probabilities, probability of x greater than x given, y is greater than y. For that, I use Bayes' theorem put into R here. For the joint probabilities, x is greater than x and y is greater than y, I use the formula for dependent variables. Later on, I do here a table of counts. That I just use a matrix. And here's my matrix here. This is my total column. This is, you'll see the matrix function R goes by column. So 1, 2, 3, 1, 2, 3. This is my total for y being less than the small variable y. So A and B are new variables. A is all the observations above the third quartile. I already have that, but I save it as A and B for convenience. And the question is, does the probability of A given B equal the joint probability of A and B? So we want to check mathematically and then evaluate by running a chi-square. Mathematically, this statement evaluates the false, and then I load the mass package and I do the chi-square test, and I get similar results with a minimal p-value. My univariate descriptive statistics I get just by using the summary function that gives my minimum, median, mean, maximum. You also see for arrival delay I get a number of NAs, and that can cause issues in R, but there are ways of dealing with it. My histogram for distance is much more jagged, much more uneven, much less normalized than my histogram for arrival delay. And then a density plot shows that even more definitively. You'll see here for arrival delay, it's almost like a small bell curve here, but it is somewhat skewed. So to get the 95% confidence interval for the difference in the means, I calculate a t variable using the qt function in R, and then I calculate the lower and upper bounds using the formula for the difference between means. Here's my interval. I derive a correlation matrix using the COR function, and I use COR.test to test the null hypothesis that the correlation is 0, and also give me a 99% confidence interval. This is my interval, and this is my correlation, which does show a slight negative correlation, meaning as one goes up, the other goes down, but it is somewhat small, so it is a very weak correlation. And the precision matrix is meant to provide a direct connection between the two variables, whereas the correlation can be explained by perhaps a third variable connecting the two. The precision matrix shows a more direct relationship, although again it is very slight. I use my y variable that's skewed to the right. I add 71 to every value in the set using na.omit, because again there are a bunch of na values in there, and I use fit to fit to a probability density function. I take the estimate parameter of that data, that's maybe my lambda value, and I use that to create a random sampling. And then my histograms for the new probability density function data is very similar to my original histogram, but it is more spread out. Then I use functions such as qnorm and quantile to get 95 to get confidence intervals, also to get the 5th percentile and 95th percentile, comparing the original variable with the probability density function data. And that's my project for the data science math bridge course.